We begin with a simple analogy to get across the most basic principle of the mass spectrometer. Three balls of equal size but different mass. The lightest, the ping pong ball, straight down and straight through. Somewhat heavier, golf ball, straight down and straight through. And the heaviest, the snooker ball, straight down and straight through. A hairdryer would be put on at this point, blowing air from right to left. Look at the deflection of each ball. 5 for the lightest, the table tennis ball, 3 for the golf ball. And what about the heaviest? Snooker ball has the least deflection, score of just 1. Conclusion then is the ball with the greatest mass is deflected the least. In the mass spectrometer, a magnet plays the role of the blow dryer. Look at the labels: a heater element to create a vapor, an ion accelerating field which gets the positive ions streaming from left to right towards the magnetic field, a detection plate at the top right there. The entire mass spectrometer is enclosed and is evacuated. There are no air particles inside, so that the beam of ions has a free run. No air particles to strike. In the copper color you see 2 rectangles. One at the bottom is the electron gun. It's an element which is heated and generates electrons which are attracted towards the capture plate, the larger of the copper colored rectangles. This produces a beam of fast moving electrons. Entering at the bottom left there you see the sample represented with green spheres. If it's not already a vapor, your sample will have to be heated to create a vapor. We'll have, our sample might be ions, atoms or molecules. If it is atoms or molecules, we have to change the atoms or molecules into ions. This is the role of the electron gun. The electrons will knock off 1 or more electrons from the atom or molecule. When an atom or molecule loses an electron, it doesn't affect its mass, as electrons have negligible mass, but it will create a particle which has a positive charge, or 2 positive if it loses 2 electrons. Adjacent to this field is a positive plate, and the moment positive ions are produced, the positive plate will repel them from left to right towards these blue spheres, which represent plates with slits in them, and the role of the slits is to focus the beam. Watch now as the green spheres turn to red, brown or yellow, creating ions of a different mass to charge ratio. You'll see the yellow spheres represent the ions with the greatest mass to charge. They're deflected the least, whereas the brown, they're deflected the most. They're the ions with the lowest mass to charge ratio. As they reach the detection plate, they create a small electric current which is amplified, and this produces the stick diagram that you see in the spectrum on the top right. The more ions of a particular mass to charge ratio, the greater the current, and the taller the stick in the spectrum. Therefore, the taller the stick, the more abundant that ion of that particular mass to charge ratio. So there's the red going through. It would represent, I suppose, the golf ball in our earlier analogy with the moderate mass. So what are the summary points or key points? Tiny amounts of sample, very tiny, are required for mass spectrometry. The sample must be changed to a vapor. So if it's a solid or a liquid, it has to be heated. 1 or more electrons are removed from the atoms or molecules to produce positive ions. An ion accelerating electric field, together with plates that have slits, form a narrow beam of positive ions. The magnetic field deflects the ion beam, or the ions in the beam. The ion with the greatest mass and the smallest charge is deflected the least, like the snooker ball in our analogy. Ions hit a detection plate, producing a tiny electrical current that is amplified. The more ions of a specific mass to charge ratio, the greater the current and the taller the peak in the spectrum.